initially I was doing about shampoos that straighten your hair, but after some research, it appeared to be that shampoos can't straighten your hair. What they're doing is they're just like putting a protective layer over your shaft, and then you use a hair straightener comb to do everything. Okay, so first of all, we need to talk about the hair structure to understand how relaxers affect it. Sorry, I'm trying to move the zoom. Okay. Hair shaft has three major layers. So cuticle on the outermost, cortex on the inside, and the medulla in the inside. So cuticle is the protective part that's made out of overlapping dead cells. Cortex is the main part that holds 90% of the weight, and it affects characteristics of the hair like elasticity, color, and etc. Medulla is the marrow of the shaft, but it doesn't really do anything. It's present only in horse or blonde hair. And for future, pH of hair is between 4.5 and 5.0. It's important to understand how relaxers affect it. Yeah, okay. Yeah, so here's the cortex. Like the most important part of the hair. My research is mostly based on it. So as you can see, like cortex is made out of long protein chains. The dominant protein in cortex is alpha keratin. It's a fibrous protein that has only primary, secondary, and tertiary structures, and there are no quaternary structures that are not used here. So, and important information is that keratin filaments are held together by disulfide bonds. Actually, there are also hydrogen bonds, but they're not the strongest and the most important bonds here. Disulfide bond is the covalent. Covalent. It's not as strong as carbon-carbon bond or carbon-hydrogen bond, but its collective strength is doing its job. And the shape of hair is determined by the cross-link angle between two sulfur atoms. If there is no angle, if it's like 180 degrees, then the hair is straight. If there is an angle, hair becomes curly. So chemical relaxers. There are two most common types of chemical relaxers. They're thioglycolates and hydroxides. The most common thioglycolate is ammonium glycolate. Here's the formula. It's long. Yeah, I'll rather not pronounce it. And yeah, and the most common hydroxide relaxer is sodium hydroxide, and it's the strongest and the most dangerous and destructive relaxer. Hydroxide relaxers are really dangerous, and only specialists should apply them and be careful. So their pH ranges from 12.0 to 14.0. You can see they're pretty basic, like really basic. What they're doing is they are triggering the process of lanthionization. They're destroying those disulfide bridges, as we've seen before. Yeah, those ones. By replacing the SH group with OH with the hydroxide group. Thioglycolates are much safer than hydroxides because the ammonia group is covering the shaft of the hair, so protecting the shaft, while glycolate is breaking the disulfide bonds by reducing the disulfide resistance. And their pH is much lower. It varies from 7.0 to 12. Usually it's between 7.0 and 9, actually. What did I not say? Yeah. So safety precautions. Everything should be completed by a specialist, of course, because excess of any of the relaxer, even of thioglycolates that are much safer than hydroxides, can cause your hair to go limp because all disulfide bridges are being broken and nothing holds them together. Moreover, when you apply a relaxer, the cuticles are being opened and the hair increases in size. So if you don't do anything, if you don't neutralize it, thus return the pH of hair to normal. Cuticles are going to stay opened, and the cortex, the most important innermost part, will be exposed to external denture. So some good neutralizers are lemon juice or citric acid with pH of 3.0, vinegar or acetic acid with pH of 2.3, or special neutralizing shampoos. And it's also should be known that since these chemicals are basic, they are dangerous for skin. So in particular, sodium hydroxide can leave burns on your skin, and while ammonium thioglycolate can lead to other allergic reactions, like like also burning your skin. And there is one important environmental aspect of sodium hydroxide, that is, if it's released into air as an aerosol in water, it's going to be neutralized by carbon dioxide and fall on the surface as salt, like, for example, sodium carbonate. And that's harmful for soil and aquamarine life. Yeah, thank you. Here's my work cited. Thank you. Just a second.
Very good again, Victor. We're very happy with that. Okay. So